This is our robot, and it has many unique aspects that we want to share with you. A truly remarkable aspect of our robot is, I believe, the code. The code has three separate aspects that make it truly unique. One is that it uses a check conditions function to select a state for the finite state machine. Then in the finite state machine, it uses that state and selects an action function. And then in the action function, it triggers the actual action of the robot. This made it super easy to debug, and it was able to have everything super compartmentalized and secure.
As for the hardware that we used in our robot, we tried to use digital sensors everywhere that we could. The only analog sensors that we used in our robot were 3 QRDs for line following and then a photodiode for the laser transmission system. Every other part of our system uses IR proximity sensors. We also relied heavily on 3D printed parts, especially for ball pickup and ball drop-off. We also used 3D printed parts to get around our wiring and breadboard, especially for our laser transmission system.
So as you can see, we have 2 picks. That's a unique feature to our robot. We actually decided to do this. We were going with 1, but we realized that we ran out of PWM pins. And so we were trying to run it off the same pick, the PWM for the servo motor to drop the ball and also to do the transmission laser. But we realized, or we found out that we just had an integration nightmare with that and it would never work. So we decided to just use a simple solution, get another pick, and program that one separately. And we didn't even have to make the microcontrollers talk to each other because we just set a timer and how to do it, do the transmission function at the end of about a minute.
One aspect of our design that changed significantly throughout the semester was the way that mass was arranged across the base of our robot. We planned to place the wheels at the center of the base, as we felt that this would give us the greatest control over the position of the robot. The goal was to make it rotate about its center during turns. We also planned to have the robot lean backwards against a caster, and in doing so we need to be back heavy. However, as the ball collection hardware changed throughout the semester, we found that it ended up having more mass than we had initially planned, and the robot started to tilt forward, so we had to add a metal counterweight to the back of the robot to keep it balanced the way that we wanted. If we were to redesign, we would likely shift components towards the back of the robot, or make our ball collection lighter to make this mass unnecessary.
Some of the aspects that we would change as far as the hardware goes is we had a base plan of how we would lay out our robot, but we didn't have it completely solidified, and I think that hurt us in the end as we had to add new parts. Another thing is that we definitely would have thrown everything on a proto board if we had to do this again. The breadboard caused a lot of wiring issues and a lot of wires that came undone or were not secure, and having a soldered on proto board would have made wiring a lot more stable and secure, and we would have had a lot less issues that were caused due to poor wiring or wires becoming disconnected.
Most of it's to inbound. Right.